notation. Scientific notation is a way for us chemists and scientists to write very, 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 very large numbers, or very, very small numbers in shorthand. Alright? So we have this beautiful number. That number right there. This is a number that you will grow to learn and love. Okay? This is Avogadro's. What?
All it sounds the same thing.
Avogadro's number. Okay? This is a very, very large number. Alright? Nobody is going to be sitting here writing this number out every single time you got to use it. Okay? So now, scientific notation tells us, okay, if we figure out where our decimal point is, where's the decimal point here?
Nowhere.
I'm asking you.
At the end.
At the end, if you have a number, no matter what, the decimal point will be at the end. Right? From just a regular number, decimal point that is not a very small number, decimal point is at the end. Okay? 0 to the back. Alright? So now, when you're writing scientific notation, there's a base that you have to take into consideration. That base right here is a number times 10 to an exponent. This number right here needs to be between 1 and 9.9. This number here can be any number. Positive or negative. A positive exponent will indicate that you have a very large number. A negative exponent will indicate that you have a very small number. Alright? So now, how do we get to our number between 1 and 9.9? You find out where your decimal point is. And then you're going to move your decimal point in the direction that would give you a number between 1 and 9.9. So here, in Avogadro's number, which direction do we have to move our decimal point?
To the left.
To the left. How many spaces do we have to move our decimal point? This number here, this is how many spaces you have to move your decimal point to get your number between 1 and 9.9. The positive or the negative. If you have to move your decimal point to the left, you will be a positive number. If you have to move your decimal point to the right, you are a negative number. So again, how many times do we have to move our decimal point to get to a number between 1 and 9.9? 23 times. If we move our number 23 times, where does our decimal point land?
6. Number 6.
Right? Before the 6.
Oh,
Right? So now, if I want 4 significant figures, write me this number in scientific notation.
6.022 times 10 raised to the power 22.
What do you think? Think so? I think so too. Questions?
Just curious, why would you move it to in between the 6 and the 0? Like, why wouldn't you stop between the 2 and the 2 or
Okay,
the 0?
alright. So if we're moving and we stop right here,
The number's larger than. It's going to be more than 9.9.
stop right here, right? The number to the left is how much?
It's 2.
No,
The whole number.
this whole number.
Oh, 602.
No. 6,000 22. Alright? If we move it, that's not between 1 and 9.9. If we move it between the 2 and the 2, the number to the left is how much? 602. So that ain't gonna work. If we move it between the 0 and the 2, 60. Still not gonna work. So we move it between the 6 and the 0. So that therefore gives us 6, which falls in between 1 and 9.9. Do we get that? Okay. So yes.
Are there 24 significant figures in Avogadro number?
No. Wait. Yes. So, here we go.
You gotta move it to the right.
You have to move it to your decimal point to your right. So now, what is the sign of your exponent?
Negative.
Negative. Good. Now, how are we going to get to my number between 1 and 9.9? Where do I stop my decimal point?
After the first two?
After the first two?
Wait, after
Six,
but.
six, after six.
After the 6? Who said after the first two?
Me.
Why you say first two?
Because I thought you had to be nice. Oh, okay.
So if you put a decimal point here, oh no, Lord. How much would be the number to the left?
600.
Oh, you gotta. Okay. Now I see, because I'm reading it from.
Didn't I tell you we read from left to right? Right?
Wow, yeah.
So, where am I stopping my decimal point?
6.
After my 6. Good. So that gives me 6.022 times 10 to the negative. I hear 15, I hear 16.
16.
We not counting? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Do we see? Bless you. Okay? So here, another example. You have this number. Is this a large number or is this a small number? Large number. So if we were to write this in scientific notation, we're moving our decimal point which direction? To the left. How many times? 10 times. So we get 1.001 times 10 to the 10. If we had this number, this is a what kind of number? Very small, very large?
Small.
Small. Which direction are we moving our decimal point? To the right. How many times?
7.
7 times. What is my exponent? Negative 7. Good. So this is just telling us what our values for the ends are. We know that. So again, positive n means that you have a very large number. A positive exponent. If you have a negative exponent, you have a very small number. Now, if we were to go, if you had your scientific notation, and I tell you that I want my number in normal notation, if you have a negative value, a negative exponent, which direction do you need to move your decimal point in order to get to your normal notation? To the left.
Minus 16?
Uh-huh.
Move it to the left.
You move it to the left because in order to get your negative exponent, you moved it which direction?
To the right.
To the right. So now to reverse that, you gotta move it to the left. And your positive, you gotta move it to the right.
Sorry, I missed.
Okay. Your negative exponent, your negative exponent, which direction from your normal notation did you move your decimal point in order to get a negative exponent
To the right.
to the right. Alright? Now, I'm telling you that I give you my scientific notation and you have a negative exponent. I want now my normal notation. Which direction now do you have to move your decimal point to get your normal notation?
The reverse.
In the reverse, what's the reverse?
The reverse of left, middle, left.
So therefore you gotta move it to the left. You get it? Alright, here we go. Write the following in normal notation. What is my value for, what is the normal value for 3.72 times 10 to the 5th? Lisbeth.
Sorry. Move it, to the right.
So what's my value? Huh? What's my value?
Wait, sorry, I was, is it a 3.72?
Yes. Times 10 to the 5th. What is a normal notation? So what, how do you write it out normally?
So 4 zeros after the 3. 0.000. No.
Okay, so this is a positive. Which direction did you move your decimal point to get a positive exponent? Okay.
After the 2. No?
What after the 2?
The zeros.
Okay. So tell me, what do I write?
So it's 4 zeros after the
Tell me what I write from the start.
It's 3. So it's 372, 0, 0, 0. And then this 0.0, of course, at the end. Right,
No.
no.
If there's 0.0,
But it doesn't count, though. No?
This is significant figure.
It's just the 3 zeros.
why would this be wrong?
Because the trillion it counts.
Right, okay.
Because now you've added a decimal point, so therefore your trailing zeros now count. Okay? Keith, you had a question? No? Sure? Okay. Janice?
Hold on, I didn't write it out yet.
Okay.
So it's gonna be, 6 zeros, 8513.
Is this right?
Zero, what, 0 points? The big. Yes.
We must include our decimal point. Okay?
We do it for the opposite way because we need those to be significant. Is that why you put the
No.
decimal point?
What, why you put this here?
Yeah.
No, we do this because if you just had that, that's not a number. Okay? The decimal point indicates that this would be
So
your
when
number.
when you're
Because
going,
remember, you're moving your decimal point these places, so you can't just drop your decimal point. You have to add your decimal
so
point.
how come we dropped it for the other one?
Because this is the whole number. If you put a decimal point and a 0 there, you're increasing the significant figures.
Okay.
This one, why does this not increase the significant figures?
Because it's nothing.
Because a leading 0 is not significant.
Okay.
So, for the second number, there's 7 zeros in all.
6 zeros.
6 zeros. Because remember, you have to count your 8. 8 is one of them.
So it's 0 point.
Oh, you can mean this zero up here?
Yeah, so it's 0.,
0.60
okay.
8513.
So you add this 0 point only when the figure is negative?
Yes. We good?
Yeah.
Great, next one. So we're gonna write these in scientific notation now. Genesis. First one's yours.
We're gonna move it to the left, right? The
Gonna
decimal.
move it to the left, very good.
Would it be 87256? Times 10. To the power of 1.
How'd you get that?
Move the decimal once to the left.
So you
I mean,
moved
to
it
the
to the right. Why would you move it to the right? Remember?
Oh, I'm sorry, I went the wrong way, it's to the left, right?
Okay.
So it's 0.8725 times 10. So 104.
Alright? Remember, this is our base, right? What does this number have to be?
Between 1
Oh.
Ask me from 1 to 9.9.
Very good, 1 to 9.9. What is this number? What can this number be?
It's positive.
So this can be positive. What does a positive number indicate?
How many places we're gonna move the decimal?
How many places you're gonna move the decimal in which direction?
To the left.
Very good. How do we know that we need to move it to the left?
Because we have to have one significant number.
We have to have one significant number. Where?
On the left side of the decimal.
There you go. Alright? So now, here, which direction do we need to move our decimal point?
To the left.
To the left. How many spaces, how many times you need to move your decimal point to get to a number between 1 and 9.9?
3 times.
3 times. Okay? So if you move it 3 times, where does that put our decimal point?
Between 8 and 7.
Between 8 and 7. So therefore, this number now becomes what?
3.
What 3?
Positive.
Positive 3. Get it now? Alright. Now I want you to do the next one for me too.
Write it down in simple enough.
So it's gonna be 0.00729 times 10 to
Oh,
What if I had a number two?
Write it down.
7.29 times 10 to the power -4.
Okay? That's what I got to. Do we get that? Good. Accuracy and precision. Accuracy is simply how close your measurements in the lab are to the true value or the accepted value of your particular measurements. Right? Precision has to do with if you do your experiment 5 times, how close they are to each other. Right? Do we get that?
Yes.
Good. Now, dimensional analysis. Dimensional analysis, all that is conversion. How do you convert one thing or one unit to another unit? All right? So let's take, for example, let's bring it home. How do you convert $1 into quarters? What's the conversion factors there? $1 is equal to 4 quarters. That's it. That's the conversion factor.
Equal to 1 hour.
Huh?
Equal to 1 hour for parking.
Oh, okay. Actually, not 1 hour in Manhattan.
Sorry.
Not in Manhattan. You get like maybe 45 minutes tops. Okay? So, here you have another example of conversion factors. Okay? Conversion factors will always have 2 units. These are the 2 units that you need for your conversion. Okay? You're going to have a given unit and you're going to have the unit that you want. Here, 1 inch is equal to 2.54 centimeters. You can have 2 setups for this, depending on what's given. Which unit is given to you, you have these 2 setups. Right? So if, okay, bet. This is I don't know if anybody else does this, but this is what I came up with. For every conversion factor that you do, you're going to take this setup, this is going to stay with you forever. If you learn this, you're going to take this with you to 202, you're going to take it to organic, you're going to take it to whatever math that you take. This setup will never fail you. Promise. Okay? Now it all has to do with units and where you place things. Alright? In your brackets. Your brackets contains your conversion factor. Alright? Now, here it depends on your units. Out front, this is going to be your given units. Your given units is units that you want to get rid of. Your given units can be found in your conversion factors. So in order to get rid of your given units, it must be inverse to each other. So therefore, up top will be the units that you want. This will never ever fail you. You can have several of these, several conversion factors lined up, and would always be the equation, the given must be inverse to each other. The units that you want must be up top. Okay? Do we get that? Alright. Let's take an example. What is the length of rope is measured to be 1834 centimeters. How many meters is this?
18.34 centimeters.
18.34 centimeters. So what goes How, in terms of you setting this up, setting up our conversion factor.
So the 1834 is up top.
1834, is it up top?
Over there, so yeah.
It goes all on the outside, left-hand side, 1834 centimeters over 1. What goes in your brackets now?
100.
The meter up top.
Meters come top, how many meters?
One
X, no, not X
1 meter.
meters.
1 meter.
1 meter
Over 100.
over 100 centimeters. This is your conversion factor.
So it's always 1 over 100?
No.
So then where you get the 100 from?
Alright, what is the remember, okay, bet. Length. Base. How do you go from base to centi?
Multiply.
100, not 1,000. Remember, it's
10.
the thousands is base to milli, then to micro, then to nano. In between base and milli, you have 2. What are they?
The deci.
Deci, how much is deci?
10,
And how much is centi?
100, okay.
Right? So the conversion factor is 1 meter equals 100 centimeters. Alright? So now, there's some steps that we need to take. Alright? First thing you're going to do is cross out your given units. Then you're going to multiply across and then take that number and divide by the bottom. Do we get that? So now what's my answer?
18.34 meter.
18.34
meter.
Huh?
The
What?
answer is 18.34 meters.
Here, divide by 100.
Yeah.
Oh, you see, it should be 18.34. You did.
What did I say?
When I said how many centimeters, you said 1834. I said 18.34.
No, I said 1834, homeboy. I said 1834. Get it together. Okay? Right. So now, is this answer correct?
Yes.
Wrong.
What?
What is it saying?
It's not,
Why is it not?
because it's not 3 significant figures.
How you figure you need 3 significant figures?
Because you got 100 centimeters on the bottom.
That right there is your conversion factor.
Yeah,
Your
but-
conversion factor does not tell you how many significant figures you need. How do you find out how many significant figures you need?
What they ask you.
What they ask you? You go back to your question. How many significant figures are in your question? 4. So therefore your answer needs to have 4 significant figures. Alright, last one. Convert 8.00 meters to inches. What do I do?
So what you got?
8.00 meters.
You want to do number 1?
Meters at the bottom, how many?
100.
Don't you have to convert to centimeters first?
1 meter
1 meter where?
on the bottom.
1 meter.
100 centimeters.
What do you do next?
Chambers.
Cross out your meters. Then you multiply across. Then divide by the bottom. What do you get? 800 centimeters. So now you're going to say yes.
Why not use the .00?
What point zero zero zero?
There's no point 000.
No, 8.00.
Times
No.
8
8.00
times 100.
times 100.
So 800, not 800.00.
No, no.
No, why you adding them in zeros? So now you're gonna take this answer and you're gonna make a new conversion factor setup. Okay? So 800 centimeters over 1 times
100 centimeters. I mean, 1 meter.
1 inch.
It's inches. We're trying to find inches.
Oh, I'm sorry.
what goes up top? 1 inch. What goes on the bottom?
2.54
2.54
centimeters.
centimeters. What do we do next?
Divide,
Cross out centimeters, multiply across, divide by the bottom. What do we get?
314.96.
314.96 minus 2
Inches.
inches.
So wait, how did you get the 2.54? So could
Yes.
That's the 2.54 centimeters equals to 1 inch.
Okay? Some of the conversion factors, like the inch to centimeters, I would give that to you.
okay, thank you.
Okay?
So would we round up?
You tell me.
Yes.
Yeah.
So how do you figure with 315? Like where you getting that number from?
Because there are 3 significant
Yeah,
figures.
right.
Where do you get that you need 3 significant figures from?
The beginning. With the
There you go. From your 8.00, you need 3 significant figures. Where's my cutoff?
Between the decimal point says 3.15.
You look at your neighbor.
It's more than 5.
Neighbor is more than 5.
3.15.
3.15.
No, what?
That's what I thought we were
Oh, my bad.
talking.
It's 315 point. Yeah, 3.15. My bad. You know what I meant.
I did. You sure?
Inches.
315
Inches.
inches. Okay? So now, if I were to tell you to write this in scientific notation, what would it be? 3.15 times 10 to the inches. Yes?
So because there's too many zeros after the decimal, wouldn't it make it like a leading zero and it wouldn't be significant? Do you still have to count them?
Okay, so where are my leading zeros? Where do you find them?
After the decimal point?
No, ma'am. Leading zeros come going left to right
Okay.
before you hit a non-zero number.
Okay, I got you.
Alright? So now,
Why is it 10 to the 2?
how much, where the decimal point here?
Right there. Oh, okay. And then there's 2 things.
What do you mean 2 things after?
I don't know.
How you write this in significant in scientific notation?
Oh, okay.
Yes.
So when you're converting, and you have to do like 2, like this problem,
Yeah.
Uh-huh.
you would always have to change it to the appropriate figures before you.
So no, you take your answer here, whatever the answer you get here, you carry it over. You round only at the end. Okay? If you round every step, you're going to get the wrong answer from me. You must round at the end of the end only.
Wait, round or significant figures?
Same thing. Okay? Now, if I wanted this number in 2 significant figures, what would it be?
3.2 inch.
3.2?
3.2 inches.
3.2 inches. So I have 32 inches and 3.2 inches.
It's 320.
3 inches.
3.2 times 10. 10 to the 1.
3.
Wait, what are you asking for?
I want this number
Uh-huh.
in 2 significant figures.
Okay, so then it's 3, the second one.
Wait, tell me, Ronnie, tell me what you said again.
3.2 times 10 to the 1.
That's
Yeah,
scientific
that one.
notation though. That's scientific notation, that's completely different.
No, I said 32.
32.
32 is 0.
Huh?
3.5.
Wait. We're going from 315 though.
Yeah,
We get 315.
I like the it, I think
If
the
you
last
use it, what if you, how you do that? Because
Oh,
it's
right.
less than that.
But we
It's
want
way-
two. There's
No,
three
that's thinking
significant
about the
things
right
now, no?
Right,
No.
320
We
is
want
significant,
two.
You
so-
cannot do that, because
It's
it's
32.
already I mean, like, it's
No,
not,
no,
it's
no.
the last, it's, we
Think
don't
about
have the last one.
315.
There wasn't that one.
Oh, yeah.
Because two significant figures,
It's
three.
320.
You got them up? I don't know, girl. Tell me.
To round up. It cannot be, 315, it cannot be 32, right?
There you go. This, how much is this here?
315.
315. Only just subtracted that to 32. Something wrong. So this is a no-go. Over here, you went even further down to 3.2. That is also a no-go. This one right here, if you translate this in from scientific into normal notation, what is this equal to? 32. So again, this right here is also wrong. This right here is also wrong.
Was it right then?
It's impossible.
No, it's not that it's impossible. This right here, I don't know who taught this that, you know, you just add a zero here and you round up and that makes that okay.
Oh,
No,
so it's 317 or 3.
no, 317. What are you adding to?
You know what? Let me be quiet and let you tell me this. Right.
You ultimately, remember, anytime you have a number here, you have three significant digits, and you want significant numbers lower than the number itself. You must write it in scientific notation.
Wow.
Okay? Now, the one thing that was wrong with Ronnie's is that his exponent was off. So it's 3.2 times 10 to the second inches.
So after you get, if they ask you, after you get your answer, then do that? Or they're gonna ask you?
So I would ask, write the answer in scientific notation.
Oh, okay. So then get the answer, then do that. Okay.
Right.
3.2 times 10 is about 2 is the same as 320.
No, it's not. If I were to ask you to write this in normal notation, then you would give me this.
Okay.
Right? But going from here to here, to here, no, we don't do that.
Okay, so you do ask me for like the two significant figures, so we have to write down the scientific notation.
You have to write scientific notation. If I were to ask you for one significant figure, what would you write?
3,
3, yeah.
3 times 10 to the
10 to the third, and third, yeah.
10 to the second.
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 How are you going 10 to the third? It has to stay right here.
Yeah.
Okay? Tell me.
So to clarify, the answer's not 320 because that's more than 315, right?
It's not that it's more than 315, it's how you write these things. You don't just round up and add a zero.
Yeah.
You don't that. You must write this in scientific notation.
Professor, can we write like 3.15 times 10 is to the power 2?
To the power of 2?
Yeah,
That's this right here.
that's correct.
Of course that's correct. But I'm just giving you other examples. This is your answer. This is your answer if I ask you to write it in scientific notation. This is your answer if I ask you to write it in scientific notation with one significant figure. This is your answer if I ask you to write it in scientific notation with two significant figures. Do you get it?